All right, so here is the, or let's take a look at the different equations for each of these. Okay, so let's look at monthly first. So in a monthly one, okay, our amount is going to equal the principal times 1 plus, okay, what goes next? What do we put in the top of our fraction here? 8%, which is represented what in decimals? 0.08 over, and if it's compounded monthly, what do we divide by? How many compoundings? 12. And we're going to multiply, or take that to the power of the number of compoundings times the number of years, which is 5. So here's our monthly. Okay, let's compare that to our daily compounding. So we take our amount, principal times 1 plus, again, we're dealing with 0.08 is our interest rate. How many compoundings will there be if it was compounded daily? 365, assuming it's not a leap year. We take 365 times 5. Okay, and then let's take a look at continuously, which you guys don't have a formula for, so I'm going to give you that formula. The formula for continuous compounding is the principal, P, times E, the natural base, to the power of RT. Okay, so we're going to take P times E to the power of our interest rate, which was 0.08, times our years, 5. Okay, so for each of these, what value is P? P is the original principal, the original amount invested. So we'll replace P with 1,000 in each of these cases. Right, so if we evaluate these, we have 1,000 times the quantity 1 plus 0.08 over 12, all to the power of the quantity 12 times 5. Okay, and when we hit enter, we get 1489.85. Remember, anytime you're dealing with money, I'm not going to specifically tell you what to round to, but you should be rounding to the nearest cent. The cent is the second decimal. Right, so if we were compounding this instead of once a month, if we compounded it every single day, do you think you're going to make more money or less? Remember, every time it's compounded, it includes the amount that was made previous to that, right? So it should be compounded, like it should be a little bit more. Let's take a look and see what happens. So here we take 1,000 times 1 plus 0.08 divided by 365, and we're going to take that all to the power of 365 times 5. Okay, and so we see we get 1491.76. And then what about if it's compounded continuously? Like every single instant, you're gaining interest on what you have in there. So do you think this should be even more? Should it be a lot more or just a little bit more? You would think a lot more, right? So let's take a look at it. Okay, so if you take 1,000 times the quantity, and then here we have E to the power of, and in the parentheses, 0.08 times 5, and we get 1491.82. Okay, so it is a little bit more, right, but not what you think. And it's that idea that it's not what you think is sort of that finite differences. It's not going to continuously increase at the same rate that you think it is, right? So you see here, when you go from 12 compoundings to 365, it only went up less than $2. And from 365 times to an infinite number of times, so again, it's being calculated every instant that it can, it only goes up 6 cents.